the heat fuses the soot, forming what will eventually become the core of the optical fiber. The glass tube itself will form the fiber's covering. When there's enough fused soot, they turn up the heat until the soot itself turns into glass. Then they heat the glass tube enough to soften it, as well as the new glass inside. The intense heat eventually makes the tube collapse on itself to form a solid rod. The internal structure of the optical fiber has been achieved. But it's in the form of a big bulky rod called a preform, so the next step is to thin it out. First, they excise the preform from the uncollapsed section of the glass tube. Then they install it vertically into the drawing tower, which will draw out the final shape. The drawing tower's oven heats one end of the preform to 2,000 degrees Celsius. The glass softens. Gravity helps pull it down, like honey dripping from a spoon. Then, using a glob of glass as a weight, they stretch the soft glass and keep stretching it until they formed a thin glass fiber. A series of pulleys measures the tension on the fiber as it's being drawn. A special monitor makes sure the fiber's precisely the right diameter, 125 micrometers. That's about 1/8 of a millimeter thick. Then the fiber passes through UV lamps that bake on an acrylic coating to protect against dust and other contaminants. Finally, the fiber is rolled onto a drum. From here, it's either shipped out as is or put into a cable. Fiber optic cables are expensive to produce, but they're smaller and lighter than traditional copper cables. They carry more information and need fewer repeaters to keep the signal from deteriorating. And unlike copper cables, they're immune to electromagnetic interference. They're also hard to tap without being detected. And all this is made possible by a complicated process based on a very simple principle: light traveling through glass. Those three little pigs knew what they were doing when they built that brick house. Not only are bricks wolf-proof, they're also fireproof, pest-resistant, and weather-resistant. No wonder they're one of the world's oldest building materials. Bricks are often made of shale, a lightweight rock that splits easily into thin layers. Quarry machines dig 40 centimeters down to expose the shale to the elements for 2 years. This weakens it, making it easier to process once it gets to the factory. A 4-foot-high stone wheel with a steel tire grinds the shale into powder. It grinds up 50 tons of shale per hour. A screen sifts out any pieces that need more grinding. The powder goes to the pug mill, which mixes it with water. This makes a thick paste that will next go through the extrusion machine. The extruder forces the paste through a rectangular opening to form one long continuous piece called a slug. At the same time, it shaves off the crustier top layer to expose what will become the face of the brick. If this gray shale mixture is fired as is, it'll naturally produce a red brick. To engineer a different color, they coat the slug in sand mixed with an oxide mineral such as zinc or iron. Next, they texture the surface with a textured roller. This is just one of many popular designs. Then, a large knife comes down like a guillotine and slices the slug into 5-foot lengths. You might be wondering where those 3 holes came from. Well, remember how the paste goes through the extruder to form the slug? Inside are 3 pins. They make 3 holes designed to decrease the brick's weight. Out of each 5-foot length, they cut 20 3-inch bricks. The ones on the ends are uneven, so they go back into the mix to make new slugs. Next comes the delicate job of stacking these newly minted bricks to be. A machine first separates them. Then, using inflating bags, it grasps them, raises them, then stacks them. Meanwhile, the water in the bricks is starting to evaporate. To hasten that process, the bricks go into a dryer for 2 days. The dryer gets its hot air from the heat generated by the kiln, where the bricks go next for firing. The kiln is really a giant oven. It fires the bricks at 1,040 degrees Celsius. That's almost 2,000 degrees Fahrenheit. One and a half days later, the bricks are ready. The transfer machine takes them out of the kiln. But before they go to market, a technician does a quality check. He weighs and measures a sample to see if it meets the design specifications. Bricks are supposed to absorb some water, but not too much. Yet if they repel water completely, they'll also repel the wet mortar the masons use to stick the bricks together. So to test absorbency, the technician breaks a brick in half. He weighs it before and after soaking it in water for 24 hours. By comparing the weights, he can see how much water the brick has absorbed. Once the batch gets the okay, they stack the bricks into cubes of 500 to 600.